the approximate velocity at the lowest point so that one revolution gets completed is. So we have found already the minimum velocity required at the highest point, the minimum velocity required at the highest point to complete one revolution, that is 2.4 meter per second. Now, to get the minimum velocity required at the lowest point, so we just apply the law of conservation of energy. So when you apply law of conservation of energy, we get that. See here, to apply law of conservation of energy, you can take the lowest point as 0 PA line, 0 PA line. Okay, so here velocity, V. Say the velocity here is V dash. Say this point is, the lowest point is A, highest point is B. Okay, here we have charge Q, here we have charge Q. Even when it comes here, the charge will be Q. Okay. So at the lowest point, you can apply, between lowest point and highest point, you can apply law of conservation of energy. Total energy at the point A is equal to total energy at the point B. So when you consider the lowest point as 0 GPa line, gravitational potential energy, here electrostatic potential energy will not change. Why? Because the separation between these two charges remains same. Electrostatic potential energy will not change. Only gravitational potential energy and kinetic energy will change. So PE at the point A plus KE at the point A is equal to PE at the point B plus KE at the point B. So what is the potential energy at the point A? Zero. Why? Because it is gravitational potential energy, not electrostatic potential energy. So PE, potential energy at the point A is zero because it is zero GP line we have considered. Kinetic energy is half mv dash square. Potential energy at the highest point is mg2l plus kinetic energy is half mv square. We substitute all this. So half into m is, so 3 into 10 to the power of minus 3 kg. So already it's given in the question. So it's given in the question. So the mass of the object, sorry, 2 into 10 to the power of minus 3 kg. It is 2 into 10 to the power of minus 3 kg. 2 into 10 to the power of minus 3 kg into V dash value, V dash square, V dash value we had to calculate. So 2 into 10 to the power of minus 3 mass and G value is 10. So 2 into length of the string is 0.8 plus half into, so m 2 into 10 to the power of minus 3, V value 2.4 whole square. V value is 2.4 and here you'll get 2.4 whole square. So when you simplify this V dash value, you'll get approximately 5.9 meter per second. Okay, so this is how we have to calculate. Here, though we have charges, we should not consider the electrostatic potential energy because electrostatic potential energy is not changing. When electrostatic potential energy is not changing, so it will not affect the kinetic energy.